My name is Tim Setter. I'm a professor of crop physiology in the section of soil and crop science. I'm also a member of the department or section of plant breeding and genetics. My role in the NextGen project is to try to improve the flowering characteristics of cassava. Cassava lines that we would like to cross in a breeding program often are either very poor in flowering or don't flower at all. And that means that they cannot be used, even though our phenotyping and our genomic selection indicates they would be good parents. The flowering characteristics of cassava slow down the rate of progress in breeding because we have to wait a long time between planting a newly developed seed of cassava before we can make the next cross on that plant. So for example, it may be 9 months to over a year between planting and when flowering will take place. Over these last several years, we have conducted studies under controlled environment conditions where we can control the day length and have determined that cassava is a long day plant, meaning that it will respond to long days by flowering. And we have also determined that if you have too high a temperature beyond what would be considered an optimum, that will slow down the advance to flowering. What we're doing now is to determine whether or not additional light beyond 12 hours would be helpful. Interesting thing is that we don't need a lot of light to activate the photoperiod response system. So what we're using is something similar to Christmas tree lights that are red in color, which are of low quantity of light, but are of the right wavelength and are able to activate the response system. So we think this may offer in the future a added benefit to cassava breeding programs. A second way that we're approaching the timing of flowering is we're conducting studies that involve grafting between two different genotypes. So suppose we have a plant that we're very much interested in getting flowers and seed from because our genomic selection and phenotyping says it's a superior or elite line. So what we would do is we would graft that plant as a scion onto an understock that is one that is a very rich producer of the flowering stimulus which is transported in the plants. And so as an understock graft, it will have a transmissible signal that will be produced and then sent up to the scion and hopefully induce flowering. Cassava has been predicted to be one of the more successful crops in a future impacted by climate change issues. So in that respect, we look to cassava as a real promising crop to help us withstand the more challenging issues. What are those issues? Well, elevated temperature. And in the regions of the world that we're talking about, in the tropics of Africa, as well as in India and in Asia, as the temperatures rise, some crops are likely to be negatively influenced, whereas cassava is able to perform quite well at rather high temperatures. And so if you look at its performance at different temperatures, cassava appears to have better heat tolerance than many others. The second point is the drought tolerance. And cassava generally has a capability of having a deep root system that can access moisture very deep. And so if the moisture or precipitation is decreased in a region because of climate change issues and because of the high transpirational demand that high temperatures will drive, cassava is one of the better plants in terms of operating in those more drought or water limited conditions. We still have work to do to get the treatments that are successful here to work as successfully in our partner organizations. So this is where we're moving forward at this time. What I would see as success is the point in time when we have developed protocols or methods of doing work that are relatively straightforward and easy to understand, so that we can share them with a broader group of plant breeders, and that they would be successfully using the procedures that we've developed in their breeding programs in advancing the breeding of cassava as we go forward.